Hey guys, this lesson is about factoring quadratics when a is greater than 1. So, kind of like last time, we are looking to factor this quadratic. However, now there's a number in front of the x squared. So we can't start by looking for numbers that multiply to 9 and add to 11. We're going to have a different strategy. Now, the whole idea here is the same. We're breaking this into its individual factors. And so we are figuring out what is going to go inside of those parentheses. What are the linear factors that will FOIL out to get back to the original equation? Okay, so our first example, 2x squared plus 11x plus 9. So again, what tells me that I'm going to use this strategy is that there is a number in front of the x squared. If it wasn't there, if that 2 wasn't there, then we would look for numbers that multiply to 9 but add to 11. Because of this 2, we're going to have to take a different strategy. Now there's a couple of different ways that teachers teach this. I've got my method that most of the teachers at Shakopee High School use, and I'm going to show one more additional strategy at the end if you want to use that one instead. Doesn't matter which strategy you use, but just to keep things simple, I'm going to mostly focus on just one strategy. Okay, so we call this strategy the slide and divide method. So the first step is what we call the slide method, or the slide step, which is taking that 2 and sliding it all the way to the back. So whatever number is in the front here, you take and slide it and multiply it by the constant. So you take the leading coefficient, multiply it by the constant, and rewrite the quadratic, which will be x squared plus 11x plus 18. Now we can factor it the way we did in the previous lesson, which is to look for first numbers that multiply to 18, which those would be numbers like 1 and 18, 2 and 9, 3 and 6. Now that we've got those written out, which of those are going to add to 11? The 2 and the 9. So that's going to make factors of x plus 2 and x plus 9. All right, so we aren't done yet because this, if we FOIL it back out, if we undo the factoring by multiplying them, we get back to this equation, but we really want something that gets back to this equation. The last step here is called the divide step. So we call it slide and divide. We did the slide, here's how we do the divide. You take whatever this number was that you multiplied originally. Remember, we took that and we multiplied it to the constant. We're now going to take that and we're going to divide the two constants of the linear binomials. So we'll take that 2 and we'll divide it here and here. Now we have to think about, do they reduce? This one does. 2 over 2 reduces. 9 over 2 doesn't reduce. When it reduces, we'll rewrite it in its reduced form. So x plus 2 over 2 is equal to 1. And when they don't reduce, the trick is that you take whatever number is on the bottom and you move it in front of the x. And that makes 2x plus 9. So that is our answer. Now if we want to check our work, take and distribute it out, FOIL it out again. So we've got x will distribute into the 2x plus 9, and that gives us 2x squared plus 9x. Then we'll distribute in the 1, and that gives us 2x plus 9, excuse me. All right, now let's check to see if this, when we add our like terms, if this works out. So we've got a 2x squared here, right? And so that matches, that's good. That's why one of these terms had to be an x and one had to be a 2x in our factors to make that 2x squared. Then if we look at our like terms, we've got a 9 and a 9x and a 2x. Those would add together to make our 11x. And then our constant is 9, so we did that right. All right, our next example, this one's a little bit trickier now because we've got a negative number involved, but the strategy remains the same. We're going to start out by sliding this, and we'll rewrite it. So x squared minus 2x minus 24. Now we want numbers that multiply to this 24, so that's going to be 1 and 24 is an option, 2 and 12, 3 and 8, 4 and 6. Now that we have those written out, how can we make this minus 2? Well, I can make a minus 2 if I choose the 4 and the 6, where the 6 is negative. So those are going to be my two numbers. So we'll start out with this as x plus 4 and x minus 6. We did the slide part, we did some factoring, now let's do the divide part. We're not going to divide by 2 this time, we're dividing by whatever number was in front of this, the number that we multiplied. We're kind of undoing that by dividing by the 3 now. So divide by 3 there and there. In this case, the first one doesn't reduce. 4 over 3 doesn't reduce, so the 3 will move in front of the x. And on the second one, the 6 over 3 does reduce. That divides to 2, so x minus 2. Now, let's see if this worked. Let's double check our work. So 3x will multiply in, we'll distribute. That makes 3x squared minus 6x. Then if we distribute the 4, we get plus 4x minus 8. Now let's check our terms. 3x squared, that matches. My like terms, when I combine those, negative 6 plus 4 makes the negative 2, and negative 8 is our constant, so we did that right. All right, now the third example. This one's a little trickier even still. This one, both fractions are going to reduce. The previous two, only one of the fractions reduced and one of them didn't. So like this one, this 4 over 3 did not reduce. This 6 over 3 did. This example is going to have both fractions that reduce. Okay, so we're going to start it out the same way. Multiply the 6 to the 7, and that is going to make x squared minus 19x minus 42. Our factor pairs for 42 are 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. So those are all the numbers that multiply to the 42. Now we want one has to be positive and one has to be negative, and it has to add to that negative 19. That is going to work if I make the 21 negative. So 2 and 21 where the 21 is negative. All right, so that will start out as x plus 2 and x minus 21. Now we're going to divide by the 6 and reduce our fractions. So the 2 over 6, that reduces. They're both divisible by 2, so that reduces to 1/3. And then 21 over 6, they're both divisible by 3, so that goes to a minus 7 over 2. Right, so all I did, I reduced fractions there. 2 and 6, they're both divisible by 2, so that goes to 1 over 3. 21 and 6 are both divisible by 3, so they go to 7 over 2. Now that they are fully reduced, now I can take the denominators and move them in front of the x's. And so my final answer for this one, 3x plus 1 and 2x minus 7. Again, I'll FOIL it out to double check that my answer is correct. We'll distribute. That gives me 6x squared minus 21x. Distribute the 1, and that gives us 2x minus 7. Thinking about all of my terms, I have a 6x squared. That's good because that was part of the original. All right, that 6x squared matches this 6x squared. Then my like terms, negative 21 and 2, they add together and make that minus 19. And then I have the minus 7 that matches over there. All right, now this last example I'm going to do with a different method. I use this a lot in my pre-calculus class. It's more of a mental math, and if you do enough of these, it becomes a little bit more of an efficient way to do it, and I think it's more descriptive of of what's actually happening rather than just learning like math tricks. But what I'm going to do is I'm going to start by just making my factors, and I'm going to just try to fill in the blanks in a way that makes sense for this problem. Right, so I know that these first two terms, the term that goes here and here, they have to multiply to 2x squared. They're both going to have an x with them, and to make the 2x squared, it has to be like that, right? So it's got to be 2x and x no matter what. Now, what goes in here absolutely has to multiply to negative 35, so it's got to be some combination of either 1 and 35 or 5 and 7. And then when you FOIL it out, it has to add to a negative 9. Okay, so it's sometimes, like I say, it's more of a guess and check method. Now looking at this, I'm thinking that it's going to be the 5 and 7. So I'm going to try that one first. So we can say like plus 5 and minus 7, and then we're just going to check. This makes 2x squared. This makes minus 14. This makes plus 5x, and that makes minus 35. So it kind of worked out where I did it right the first time. If I check my work here, 2x squared minus 14x, and then 5x and minus 35. So plus 5x minus 35. And if I look at my middle terms, they do add up to a negative 9, so I did it right. All right, so here are 3 practice problems. Go ahead and pause the video and try to factor those on your own. Don't forget to check your work. And when you're done, unpause the video to see the key for them.